right, recording. All right, so if you did your video notes, which most of you did, thank you so much. We were talking about matter, and we were talking about how we could break it into a couple of different categories. So I'm going to kind of keep it high level because you've already done the notes. So that's the whole point of us doing notes, so we can go fast in class and get any homework done and be done. So you had matter at the top. All right, and then it broke out into different categories. So you had a category over here, and you had a category over here, and then that broke out again into different things. And eventually what you had across the bottom was solution. So most of this you should already have written down unless you haven't done it. And if you haven't done it, you can write down what I'm writing down, but you still need to do the video notes, okay? Because there's more stuff in here that I'm not writing. So you had solution, colloid, suspension on one side, right? And then on the other side, you had, this down here, element and compound. First of all of these words you're going to need to know in terms of vocab, okay? And again, I'll try to give it to you in easy terms. So let's start with the easiest one, which is the element, okay? Or we'll say the lowest or highest on the pole, however you want to say it, okay? So if we start with element, okay? Element is the only one that cannot be broken. You cannot break down an element any more than what it is, okay? You could look at the atoms in the element, okay? You could see, I mean, you can't see it, but you can see the atoms and the protons and neutrons and electrons. But if you're looking at copper, which is an element, that's it. Like you can only break it down to copper, okay? Everything else, all those other ones, they can break down at least into other elements, okay? So elements, anybody know where we find the elements? 2 words. I'm looking for 2 words where they can be found. Something T.
Periodic table.
Very nice. They are all found on the periodic table. Okay. So I have a periodic table in the classroom, but obviously we are not all in the classroom. So let me show you where you can find periodic table. My favorite one to show you is let me share here, share is here. All right, so this is called ptable.com. So here's the address right here, the address. You could just type in ptable.com. All right, can you guys see when I just circled that or no?
You can see the table.
Did you see me circle something? Can you see this?
No.
Okay, well, that is good. You know what? I've been writing. Okay, that is good to know. Let me use this one then. All right, now can you see if I do this? No, you cannot. All right. Anyway, if you look above, if you see the green box that says hydrogen, everybody see the green box that says hydrogen? Right above that is the address. It's literally ptable.com. ptable.com, okay? So these are, I just realized I was circling stuff all day today and no one told me they couldn't see anything. Okay. Well, so these are elements. They're always like a single name, okay? So you got like nickel, which is number 28, if you see that one. And actually, that's where a lot of the metals are. So you got nickel. Next to that is copper. Then you have zinc. Oh, I can use my mouse. Here we go. Let's see. So here's nickel. All right. Here's copper, zinc. You got silver, gold, platinum. You got some aluminum, tin, lead, all that stuff. And then actually, we'll talk about this later, but actually all of these are metals too. So like sodium and magnesium and potassium and calcium, all those things that we kind of think of are like vitamins. These are all metals, okay? So they all have, it's just one single thing, okay? And you cannot break it down any more than what it is, okay? So if we go back to our whiteboard here, right? Elements on the periodic table, you cannot break it down. Can't break it down physically, can't break it down chemically. It is what it is. Every day. Every day. My Zoom has been messing up all day. I don't know what's going on. Now my whiteboard is going to be gone, so I'm going to try to write it really fast again. All right, we were talking about elements. You guys can hear me, right? No?
Yes.
Oh, you can. Okay, I was like, seriously? All right. My screen is gone. Let me write that again. So anyway, now we're going to talk about compounds. I'll go back and write the other stuff. Let me tell you what compounds are though. Okay. So over here we have compounds. Okay. Compounds are two or more elements chemically, has to be chemically, trying to write it nice and neat, chemically combined. All right, you get that written down because I don't think I put that in your notes. I'll go back and write all this other stuff. This was matter. All right, so a compound is two or more elements, okay? And they have to be chemically combined, Now, if they are chemically combined, they can also be chemically separated. So what that means is we can't do something like, we can't say like, we're gonna break it apart or, you know, boil it or something like that. Chemically combined usually has to do with like electricity or fire. So it's like something really sciencey that you got to do to kind of, you have to do some type of chemical change for you to chemically separate them or for you to chemically combine them, okay? So we are aware of a lot of compounds. We just don't know that we know what they are, okay? So for example, sorry, I dropped my pen, sorry. All right, for example, does anybody know the chemical name or the letters we use for water? I bet you guys know this.
H2O.
Very nice, H2O, okay? H2O is an example of a compound, H2O. It is made of two elements. What element is this, the H? Anybody?
Hydrogen.
Hydrogen, very nice. And the O is?
Oxygen.
Oxygen, very nice, all right? So now let's think about this. That's two elements, they are chemically combined. Oxygen is a gas. We usually breathe it in. Hydrogen is also a gas. But when they chemically combine, they form a liquid, which is essential for us to live, which is water, right? All right, so they are a lot of times if you have a compound with elements that are chemically combined, they also have different chemical and physical properties. So obviously hydrogen gas and oxygen gas have totally different properties than H2O, okay? Here's another example of a compound. I wonder if anybody knows what this is. I'll be impressed if you know what this is. Anybody know what that is? We actually use it very often, probably every day.
Is that glucose or sugar?
No, glucose is like, you're close to, glucose is weird. It's like oh man, C12H14O. Wow, maybe
Yeah.
This is glucose, better known as sugar. And do not quote me on that. I need to look up what sugar is. What is glucose?
Chloride.
So anyway, say again, but you're close in saying sugar is something kind of, sort of like sugar.
Salt.
Yes, exactly. It's salt. NaCl is just table salt. And I'm pretty sure I got sugar. I think sugar is C. Let's see. I'm searching on the web. You know why? Because my C12H22O11. I was really off. So now we got 3 examples. This is 22. All right, let me just erase. Erase. This is sugar though. C12H. Oh goodness. Ugh. H22O11. That's sugar. This is table salt. This is water. But if you look at it again, it's just a bunch of elements stuck together. For instance, this doesn't look like it. I know it sounds nothing like it, but Na is actually sodium. Cl, any guesses for what Cl is? It's in the pool.
Chloride.
Chloride, very nice. Chloride or chlorine, okay? This is carbon and then hydrogen and oxygen, okay? So compounds, 2 or more elements chemically combined. There's a lot of, most of the stuff that we use is compounds, especially like around our house, like bleach, ammonia, Windex, that kind of stuff. A lot of those are compounds, okay? They're just a bunch of stuff stuck together. All right, so that is compounds. So we've covered compounds and we've covered elements, okay? Elements, check. Compounds, check. All right, then we have solutions, colloids, and suspensions, which are all types of what? Starts with the M. All types of, what'd you say?
Mixture.
Like metalloids or
Different types of mixture.
mixture.
Very nice. And mixtures actually break out into 2 different categories. They both start with H. Anybody?
Homogeneous and heterogeneous.
Very nice. Homogeneous and heterogeneous. Which one means the same?
Hetero.
The same?
Homogeneous.
Homogeneous, right. This one is the same. Means the stuff looks the same. This one means the stuff looks different, okay? All right, so homogeneous mixture, there's only one thing that falls under homogeneous mixture, and that is a solution. As a matter of fact, solution is just another name for a homogeneous mixture. It's literally the same thing. I could say homogeneous mixture, or I could say solution, same thing, okay? So these other 2, colloids and suspension, they kind of fall under heterogeneous mixture. That means they are different or they look different. So like if I was going thinking just like really out of the box, heterogeneous mixture is like trail mix or a mixed salad, right? Like you can see the different parts. And sometimes you can't see them really, really good, for instance, like milk, but there are different parts, okay? I may look and see if I can find a really cool video on milk. It's kind of interesting and gross at the same time, but that's another story. All right, so let's start with solutions. What do you need to know about solutions? Well, you need to know they look the same throughout, okay? And that's because the particles are what? Are they really big or really small?
Small.
They are very, very small, okay? The only difference between these 3 is the size of the particles, okay? Size of the particles, okay? So in a solution, that's exactly why everything looks the same, because the particles are so small. These are the smallest, And then as you go this way, the particles get bigger. Okay, so colloids are kind of in the middle. Okay, so solution, really, really small particles, so much so that when you mix stuff together, mixtures, right? When you mix stuff together, it looks the exact same throughout, okay? A suspension on the other hand, the particles are pretty big, okay, to the point where they look different. You can see a difference, and they might even settle to the bottom because those particles are so big that they may sink to the bottom of whatever you have. For example, okay? All right, listen carefully. Me and Faith are going to make lemonade, okay? Faith is a better lemonade maker than me. She is going to use, she bought a bag of lemons and she bought some sugar and she has her water and she's gonna make lemonade. I, on the other hand, not that great at making lemonade. I just bought a container of Country Time, okay? And I'm just gonna dump mine in the water. Now, whose lemonade, listen carefully, whose lemonade is going to be a solution and whose lemonade is going to be a suspension? So remember, Faith made hers with real lemons and sugar and water, and I made mine with Country Time, the little powder that you just scoop out and you put in there. Whose is going to be a solution?
You.
Right. Mine is going to be a solution. Once I mix that stuff up, you're not going to be able to tell the difference. It's going to look like yellow water, basically. Okay. But hopefully it'll taste good. Why is Faith lemonade a suspension? What pieces can you see in that?
She's gonna have like the lemon like skin almost, and like maybe even some seeds in there.
Exactly, exactly. She might have some seeds in there. She's pretty good at making it, so she may not have seeds, but she might have a couple of seeds in there. That's how you know it's real. Okay. And the pulp, remember the pulp from lemon, right? That's going to be in there. You can see different stuff in her lemonade. I'm sure it tastes amazing, but you can see the stuff. Okay. So hers would be a suspension. And if she just let it sit there, the pulp and the seeds would eventually go to the bottom. Okay. We actually drink suspensions all the time. Like if you've ever had like, especially the ones in the bottle, the smoothies, or like the quote unquote fresh squeezed orange juice, or even like the, what's the orange juice? Simply something, Simply Orange and all the other stuff. Does anybody know when you buy all those stuff from the store, there's something it always tells you to do before you drink it? Anybody know what it says?
Shake it.
Yep, it says shake well. It always says shake well. Well, why do I need to shake it? Well, because all the stuff went to the bottom. So if you actually go in the grocery store and you see the orange juice, like it's kind of gross. I mean, I know why it's there, but if you go to the orange juice section, you can go look and there'll be like a container of orange juice. Wow, that was really bad. Okay, here we go. This is why I teach science, not art. Okay, so this is my orange juice container, right? Here's the top of it. You got all the juice in there, blah, blah, blah. And if you look at the bottom, there's this like really thick layer down there. And it's all the stuff that is settled to the bottom. So they always tell you before you drink it, shake well, okay? So any of your like, if you drink protein drinks, okay, like a protein shake or smoothie or orange juice or anything that's really kind of a liquid in a can that has something heavy, it always says shake well, okay? Milk is a colloid, okay? It falls in the middle. It's not, you can't necessarily see the pieces, but it's probably just because everything's white. But there's definitely different parts of it. As a matter of fact, if you ever really read the side of a milk container, it always says, a lot of times it says, this milk has been, okay? A lot of times it says, this milk has been homogenized. Did we just say something about what this means? What does this homo part mean? What does that mean?
the same, right?
Remains the same. Very nice. Now, luckily, they homogenize our milk because it would be pretty gross for me to be drinking milk and be like, ooh, that little clump that just went down was great with my cereal. That would be disgusting, okay? But realistically, milk has different parts, okay? And the fat in milk, which is why milk sometimes, especially if you drink like whole milk and it's like really thick, okay? The fat in milk tends to go to the top, okay? So a lot of times they will put it on a machine, mix it or shake it or stir it or however you want to say it really, really fast, really, really well for a good bit of time, and it becomes homogenized, i.e. it looks like a solution, but it's not, which is why if you let milk sit for a while, it will start to get some really gross stuff going on, okay? All right, so here's what you need to know, okay, in terms of vocab. I have one other vocab word for you. I'm going to give it to you in just a second. But here's what you need to know. You need to know this word, homogeneous, heterogeneous, mixtures. Make sure you know those three words. You need to know solution, colloid, and suspension, okay? And you also need to know that these are separated by the size of the particles, okay? You need to know element and compound. And then there is one other word that I did not put in your video notes that I want you to know, and it is called an alloy, okay? Alloy. An alloy is a special type of solution, okay? So it's a special solution. Let me see if I can squeeze in here. Special solution. I'm shorthanded, but this is solution, okay? And it's a solution of two metals, okay? A solution of two metals, all right? So for instance, we talked about all those metals on the periodic table. We talked about like gold and zinc and aluminum and silver, mercury and platinum and nickel and iron and all those metals. But there are some metals that we are very aware of that are not on the periodic table. And that's because they are a mixture or a solution of two metals. For example, one of these metals is very prevalent in band. Do I have anybody in band? I believe I do. Could you tell me what a lot of the instruments in band are made of? Don't I have a band person in here? I thought I had somebody in here for band.
Metal, wood.
You do have the woodwinds, and then what's the other section in band? Anybody?
The brass.
Yes, it's the brass section. Brass is not on the periodic table because brass is actually a mixture of copper and zinc. Okay, brass is an alloy. So let's make I'll write it. I'm going to write it right here. So this is alloy examples. Okay, so you can remember alloy examples. I know I'm writing all over the board. Hopefully your notes look better than mine. Okay, alloy examples, brass is one of them. All right, there's another one that starts with BR that you may be familiar with if you're an athlete and you finish, they may give you this type of metal. Any guesses on that one? Don't have to be an athlete. Say again.
Silver, gold.
Okay, we got silver, we got gold, and you got, starts with BR.
Bronze.
Bronze, very nice. Bronze is also a mixture of metals, okay? It is also a mixture of metals. And then, all right, let me see who gets this one. Now, if you are a football fan and you are a fan of a team that actually wins, okay? You may be a fan of my favorite football team. This is who I'm a fan for. They are named after a metal as well. They are the best team in my opinion, but you know, I'm just saying. Any guesses for that one? As a matter of fact, I have on some of their socks today. You guys want to see my socks? I'll show you my socks. Any guesses first?
Bears.
The Bears?
Seahawks.
No. First of all, I said my team was good. Okay, first of all. Second of all, no. It's a medal.
I don't know.
Steelers.
Oh, the best team. It is the Steelers. Well, Steel.
Definitely not.
What? Okay, first of all, these right here. Okay, all right. My Steelers socks. Let's get it together, okay? I have Steelers there.
Definitely not the best team though.
What? Steelers. Please don't tell me you're a Falcons fan. Oh my gosh, that'd be so disappointing. All right. So I'm sorry. I do give kudos to anybody who's a Falcons fan because you have to be a real fan to speak with them. Okay. All right. So steel is also another example of an alloy. And one last tidbit, okay, before I what time is it? Oh yeah, one last tidbit. All right, and then I'm gonna actually let you guys go a little bit early. All right, here's my last tidbit. Let's say you decide to profess your love for your significant other, or later on down in life, you want to get something for your significant other, and you say, hey girl, hey boy, I want to buy you something nice. And they're like, okay, well, buy me some jewelry. What type of jewelry you think they want? Most people, the fancy one. Bruno Mars had a song about it too.
It's actually on the floor. Grenade.
I do like that song, but I'm talking about jewelry, a metal specifically.
Oh, 24 karat magic.
Yep. Very nice. 24 karat. All right. So you have 24 karat gold. Do you have any other carats for gold? Anybody know? There's at least 2 more.
2.
There might be a 2 actually. There's 2 more that I know of for sure.
6, 12, 18, 14.
All right, you're right. There's 18. There is right. You're right. There's 18, 14, 12, and then I'm thinking about 10 karat. All right. So here's my little love advice, chemistry love advice, and they'll be like, oh my gosh, she's so smart. He's so smart. All right. So obviously 24 karat gold. All right. These are different golds because the gold that we actually wear in jewelry is actually an alloy. Okay. It is not pure gold, but 24 karat gold has the most gold in it. So as you go down in carats, you get less gold. Okay. As you go down, you get less gold. Okay. Less gold. So maybe your significant other says, excuse me, you're not buying me 24 karat gold. I want 24 karat gold because that's the most expensive. You're being cheap. This is what you say. You say, okay, I was going to buy you 24 karat gold, but really you weren't because it's way more expensive. But if I bought you,
Do you have 24 karat gold money?
yeah, exactly. First of all, but you don't want to tell them that, right? You don't want to tell them that you don't have the money for it. You just want to be like, I was going to buy you 24 karat gold, but with that, it's so much easier to break or bend or mess up because gold is actually kind of soft as a metal. So the more gold you have, like if you have on a ring or a bracelet, if you bang it up against the table or whatever, it's going to actually bend. It might even break. But if you buy them 10 karat gold, you can save some money and you can say, I want this to last forever, just like our love. Because 10 karat gold has more other stuff in there, so it's cheaper, but it also will last longer. And I just gave you a love lesson for the day. You're welcome. I'm not even going to charge you guys for that one. Okay. All right. So make sure you have your, make sure you know all your vocab words. Mixture, homogeneous, heterogeneous, solution, colloid, suspension, element, compound, and alloy. Okay. That's 1. And then 2, if you haven't done the video notes, if you have, you already know how to do this, but you have to know which ones can be physically separated, which ones can be chemically separated, and which ones cannot be physically nor chemically separated. Okay. So if you do the video notes, you already had those boxes. Okay. Any questions Okay, we're gonna have a homework quiz soon, probably next week. So I just want to show you one more time. If you have not uploaded your notes, okay, so it should look something like, your notes should look something like how mine looks over here, okay? So you're gonna upload it here. So I'll show you guys, you can see if you have uploaded or not, okay? So make sure you upload your notes and you watch the ed puzzle. Now, remember, if you haven't done the ed puzzle, you can't watch the video here. You need to click 4A and go watch it here so that you can get credit for watching the video. I'm giving you a free grade for watching a 13-minute video, okay? Any questions? All right, it's a couple minutes, but it's better than nothing. I will see you guys on Monday. Toodaloo.
Bye.
Bye. Have a great day and a great weekend.
Bye, Miss Payne. Have a great weekend. Well, actually, no, I'll see you tomorrow.
Yep.
So,
Yeah. Bye.
bye.
Cameron, are you there?
Yeah, I was just,
Okay, are you gonna go do that video notes for me?
yeah, I'm watching it right now.
Okay, fantastic. Do the video notes and upload them for me, okay?
Okay.
Brandon, you there? Brandon? All right. I'm gonna get Brandon to turn his video back on.